Alright, this is the video for the final review 3A. We are skipping number 31, so the first one we are doing today would be number 22. So the thing I want to point out first with this one is that the negative exponent does not make the answer a negative number. I mean, look at the answer right there. It's 1 over 16. That's a positive number. What it does is basically flips the fraction. So if you think of this as over the number 1, it moves this 8 down to the bottom. So it becomes 1 over 8 to the 4/3. Then you have to take care of that fraction that's an exponent right now. So this is called exponential notation. So we're going to move that into what's called a rational notation here. So that number at the bottom, the 3, that becomes the index for a radical symbol. So it's what number times itself 3 times is 8. Well, I know that's going to be a 2, because 2 times 2 times 2 is 8. The 4 stays on the outside. So since this turns into the number 2, I end up with 2 to the 4th, which is 4 2's multiplied together, which is 1 over 16. Now during this video, I'm not going to pause, so if you need to pause, go ahead and just do that yourself. So moving on to number 23, I partially expanded this, meaning I wrote, instead of x squared, I wrote 2x's, and instead of 4y's, or y to the 4th, I put 4y's. Okay? So what I was doing, though, is with the highlighters, I was canceling out what I could. And by canceling, we're really turning things into the number 1. Like x divided by x is a 1. So after you do all that, you get this answer right here. So first, 63 divided by negative 9 is negative 7. What's left on the top? Well, I've got an x right there, and I've got 2 y's, so y to the 2nd. There's nothing left on the bottom because negative 9 went into 63 negative 7 times. All right, the next one here is really something you'll probably just go to Desmos and type in this equation, the y equals 2 to the x minus 4. But you might remember when we went over this that a number at the end controls whether this moves up or down. So if that number was positive, it's at plus 4, you'd move the whole graph up 4 units. But since we're writing minus 4, we moved it down 4 units. So I found 5 points and just slid this graph down 4 units, and that was my answer. Number 25. So one thing I remember writing on some of the other sheets right here is basically we're distributing the negative or the minus. So distribute the minus. So a lot of times students will remember to subtract the 2x squared, but then they won't subtract the 5x and subtract the negative 3. So that's why I wrote this kind of like the distributive property. So the 2x squared became negative 2x squared. Positive 5x became negative 5x. And then negative 3 has to become positive 3. Then you can go ahead and add them together. So I can even add a big plus sign right there. And you can see the result. X squared minus 7x plus 10. Moving on to number 26. 26 is a box method thing, although we also did a thing called FOIL. Your book has that. FOIL spells out something. The F stands for first terms, O for outer terms, I for inner terms, and L for last terms. So it's really a technique to help you multiply. That's also what this box did. So I have to put the 2 binomials on the outside, and it doesn't matter which one you put on the top and the left. But then we're multiplying the rows times the columns. You will be in a situation where 2 of them will be like terms, so when you write your answer, you can combine them. So 42 and negative 6 was 36. Now some people will write all 4 terms and then combine them. That's fine too. Now on number 27, I'm going to move out just a little bit. You can use the box method again and do the exact same thing. But this is one, if you have something that's squared like this, there is a pattern where the first term is just going to be made up of the 2x squared. So that's 2x times 2x is 4x squared. The last term is going to be the second term squared. Negative 5 times negative 5 is 25. The middle term is when you multiply these two together, you get negative 10x, and you double it to give you a 20x, and it is negative. That is called a perfect square trinomial. And I believe it came up in a couple different chapters. Trinomial. All right, number 28. All right, so what I did with this one was I wrote the prime factorization of these three terms because we have to figure out what is the largest thing that they have in common. So prime factorization means I broke everything down into just prime numbers. And a prime number, if you don't remember, is anything that can only be divided by itself and the number 1. Now, sometimes when people do this, they leave out the number 1. So I did leave out the number 1 on the second and third ones because 1 doesn't really do anything for us. So you take a look at the prime factorization yourself. Then, using the highlighters, I highlighted what they have in common. They all have a 3, so I put a 3. They all have at least 2 x's, and that's supposed to be a blue one there. So they all have at least 2 x's, so x squared, and they all have at least 2 y's. So that's what they have in common. Then, number 29 is an x factor problem where you got to remember what a, b, and c are. So a is the coefficient of the x squared term, b is the coefficient of the x term, and c is just the number. It's called a constant. So in this case, a is 1, b is 10, c is 25. It's kind of nice that they're right in order. So on this one right here, the top number is a times c, but a lot of times people will just think, oh, it's just c. They forget you're actually multiplying times the 1, but that doesn't change anything. So 1 times 25 is 25, and then the middle number goes on the bottom. So we need two numbers that multiply to 25 and add to 10, and your answer would be 5 and 5. So there's two ways you can write this. You can write x plus 5 squared, or you can write it as x plus 5 times x plus 5. Now, that one is very similar to the last one on this sheet, which is number 30. Let me pull that up. And I'm going to leave them both so you can see, because what happens is sometimes students will go ahead and do the x factor here and think, okay, I'm all done. It's just going to be x minus 1, x plus 6, just like up here. I was done. After, I just had to write the problem and the answer. Well, when a is not the number 1, there's some extra steps involved. But let's go back to the beginning here. So you draw on your x, a times c. Well, this time a is a 3, c is a negative 2. So that became negative 6. b is a positive 5. That goes on the bottom. So the two numbers that will multiply to negative 6 but add to positive 5 are negative 1 and 6. Okay, then you kind of pause. Don't write an answer because we don't know the answer yet. Then I drew in this box over here. And notice this, I have a lot of color going on here. The upper left will be the first term and include the variable. So not just 3, but 3x squared. The bottom right box will be the c, so negative 2. But what really happened was the x factor is helping us break up the 5x. So it's being broken up into a negative 1x and a 6x. So that's what goes in the upper right and the lower left. Now to get our answer, we have to get the greatest common factor, or GCF, of the two rows and of the two columns. So 3x is the greatest common factor of 3x squared and 6x. So that's the first part of my answer. Down below, because there's a negative right here, I can take it out. But other than that, it's just a negative 1. I can't take out anything else. So 3x minus 1. For the columns, they both have at least an x. and I'm not going to touch the negative since 3 is not negative. So I can just take out an x. And over here, 2 goes into 6 and 2, but once again, I'm not going to make that a negative. So my answer would be 3x minus 1 times x plus 2.